welcome back. In this tutorial we are going to study about SLR1 parser. SLR1 parser is a bottom-up parser, right? So when we need to design or construct this SLR1 parser, we need to construct two tables, action table and Goto table, right? So in this tutorial we will learn how we can construct these action table and Goto table for this SLR1 parser, right? And in next tutorial we will study how we can do the syntax analysis of a string by using these two tables, action table and Goto table, right? So as I have told you previously also in previous tutorial, the purpose of parser is to do syntax analysis, right? And in syntax analysis it is checked whether the given string is generated by a given grammar or not, right? So in this tutorial we will learn how we can construct the action and Goto table for a given grammar. Suppose this grammar is given to us, right? This grammar is given to us. Now we have to construct the action table and Goto table for SLR1 parser for this grammar. So first step is to augment the grammar. We need to augment the grammar. Right. So let us see what will be the augmented grammar of this. So in this grammar, right, we will add one more non-terminal, that is S1, right? In this grammar we will add one more non-terminal symbol S1, right? And one more production rule, S1 derives S, right? Where this S is what? This S is the start symbol. This S is the start symbol of the grammar. So when we augment this grammar, when we create the augmented grammar for this grammar, then what we need to do, we need to introduce one more non-terminal symbol S1, and we need to add one more production rule, S1 derives S, right? And rest of the productions will be same as they are in original grammar. S derives A derives A, right? And A derives B, right? Now second step is to create LR0 items, right? Now suppose we have a production rule A derives XY, right? Then how we can create the LR0 items of this production rule, right? Now see what happens. In this production rule, right, we have to place a dot on the right hand side of the production rule, right? So here wherever it is possible on the right part of this production rule, we will place a single dot. So when we place this single dot on the right part of this production rule, then we will get these production rules. A derives dot XY, right? A derives X dot Y. A derives XY dot, right? So we will get these new production rules, right? So these new production rules are called LR0 items. So for this augmented grammar, for every production rule we need to find the LR0 items. Now we have created these LR0 items for these production rules, right? Now see this production rule, S1 derives S. For this production rule we have created these LR0 items. S1 derives dot S and S1 derives S dot, right? Similarly for this production rule, S derives AA, right? For this production rule we have created these LR0 items. S derives dot AA, S derives A dot A, S derives A dot, right? Similarly for this production rule, A derives A, we have created these LR0 items, right? And for this production rule, A derives B, we have created these LR0 items. A derives dot B and A derives B dot. So now what we need to do, we need to construct a DFA by using these LR0 items. right? So when we construct a DFA by using these LR0 items, what will happen in that DFA? Each state of a DFA will consist of a set of LR0 items, right? So what we need to do, we need to construct the states of DFA, and then we need to find the transitions of DFA, right? So for that we will need two functions. One is called closure, another one is called Goto, right? So what happens in closure function? Now we will learn how we can find the closure of an item. Suppose we have to find the closure of some item A drives alpha dot B beta. First of all, you should know that the closure of an item will be a set of items, right? Closure of a LR0 item will be a set of LR0 items, right? And the item itself, whose closure we are going to find, that item itself will be in its closure. So when we are going to find the closure of this item A drives alpha dot B beta, then this item itself will be in its closure, right? So what we will do, we will add this item in its closure, A drives alpha dot B beta, right? This item will be added in its closure, right? So whenever a new item is added in the closure, right, then what will happen, in that item we will check the position of dot, right? In that item we will check the position of dot, right? So if dot is immediately preceding some non-terminal symbol, right, then we will add a new item in a closure in which the non-terminal symbol to which the dot is preceding is at left, right, and on the right side of item the dot is at leftmost position, right? So here you can see this item. In this item, this dot is immediately preceding a non-terminal symbol B, right? So here we will add that item in this closure in which this non-terminal symbol B is at left, right, and on the right side of the item the dot is at leftmost position. So this is the LR0 item which satisfies this condition. So we will add it, B drives dot AA. Now we have added a new item. So in a new item also we will check the position of dot, right? So here you can see that dot is immediately preceding this non-terminal symbol A, right? So we will add all the items in this closure in which at right hand side we have this non-terminal symbol A, and on right side the dot is at leftmost position. So here we have only one item which satisfies this condition. So we will add this item in a closure, A drives dot A. So when this new item is added, again we will check the position of dot. So here you can see that the dot is not preceding any non-terminal symbol, right? So no new items can be added now, right? So this set of LR0 items is the closure of this LR0 item. Now we will learn how we can evaluate this Goto function, right? This Goto function will take two parameters, right? First one is a set of LR0 items, right? So here I have represented the first parameter of this Goto function is I0, right, where I0 is a set of LR0 items, right, and it represents a state of DFA, right? And the second parameter of this Goto function is a symbol. It could be terminal or non-terminal, right? So here we need to find how we can evaluate Goto I0x. So what is this I0? I0 is a set of LR0 items and it represents a state of DFA, right? And what is this x? X is either a terminal symbol or a non-terminal symbol, right? So how we evaluate this? What will be the output of this Goto I0x? So for that, what we need to do in set I0, we will find all the items of the form this, in which on the right hand side the dot is immediately before the symbol X, right? We will find all the items in set I0 in which on the right side the dot is immediately before the symbol X, right? Then in these items what we will do, we will shift this dot after the symbol X, right? So these items will become like this: A derives alpha X dot beta, right? So then after that what we need to do, we need to find their closure, right? We need to find the closure of these items, right? And when we find the closure of these items, we will get a set of items, right? And that set of items will be the output of that function. Suppose that set of items is I1, right? Then I1 will be the output of this function, right? Then we can say that Goto I0x is equal to I1, right? This I1 is a set of items and it also represents a state of DFA. If Goto I0x is equal to I1, it means in a DFA there is a transition from state I0 to I1, right, on the symbol X, right? Now it will be more clear after this example when we will construct the DFA for these LR0 items. So first of all we need to construct the initial state of DFA, right? So how we find the initial state of DFA? Initial state of DFA will be closure of S1 derives dot S, right? So where what is this S? S is the start symbol of original grammar and S1 is the new symbol which we added in this augmented grammar. When we created the augmented grammar, we added this symbol S1 and we had added this production rule also, S1 derives S, right? So here the initial state of DFA will be the closure of S1 derives dot S, right? So what will be in this S1 derives dot S? First, this item S1 derives dot S itself will be in its closure, and then now you can see here that a dot is before the non-terminal symbol S. So we will find those items of S on which on right side the dot is at immediately left position, right? So here those items will be added in closure. One is S1 derives dot A, right? So now you can see, now we have added a new item in this closure, but in this new item, right, dot is not before any non-terminal symbol, right? So no new LR0 items can be added in this closure, right? So this set of items, suppose it is called I0, right? It will be the initial state of DFA. So here I am constructing this initial state of DFA. Right, and it is I0, right? Now we have to find the transitions of I0, right? So I'll find the transition of this state I0, right? First we will check its transition for symbol S. So to find the transition of this state I0 for symbol S, we need to evaluate this Goto function. Goto I0 S will be what, right? So what happens, first you can see that this set I0, right? Now we have to find the transition for the symbol S. So in this set I0, we will check those items in which right hand side dot is immediately before the symbol S, right? Here you can see that in this item the dot is immediately before the symbol S, right? So what we will do, we will shift this dot immediately after the symbol S. S1 derives S dot, and then we will find the closure, right? We will find the closure of that item, which we will get after shifting the dot, right? So as you can see that there is no non-terminal symbol after the dot, right? So in the closure of this item, there will be only one item, that is this item itself. S1 derives S dot. We cannot add new items in this closure, because here dot is not before any non-terminal symbol, right? There is no non-terminal symbol after the dot, so we cannot add any more item, right? So here I will add the transition from state I0 to on reading the symbol S, right? Now let us call this set as I1, right? So from I0 on reading the symbol S, there will be a transition on state I1, right? And here I1 will contain this item S1 derives S dot, right? Now I'll find another transition of this state I0, right? So I'll find it for symbol A, right? What will be the transition of I0 on reading the symbol A? So for that, what I need to do, in a set I0, I need to find those items in which dot is immediately preceding the symbol A. So here there is only one item. So in that item, what I need to do, I will shift the dot after that symbol, right? So I will shift the dot after the symbol A, right? So I have got a new item. Now I have to find its closure. So here you can see that in this item, the dot is immediately before this non-terminal symbol A, right? So what will be the items in the closure of this item? First, the item itself, S1 derives A dot A, right? And then we will add those items, right, on which at left side we have this non-terminal A, right? And on right side, the dot is immediately at the leftmost position. So these are the two items like this. One is A derives dot B. Another one is A derives dot A, right? Now we have added two new items, right? So in these two new items, you can see that there is no non-terminal symbol immediately after the dots. So no new more LR0 items can be added in the closure, right? So this is the closure of this item, right? Let us call this set as I2, right? So you can see that if the DFA is in state I0 and it reads the symbol A, then it will jump to state I2, right? And I2 will have these LR0 items. Right? This state I0, in this state I0, the dot was preceding in these items only the symbols S and A, right? Now see the items of I0 state. In I0 state, whatever the items are here, in them dot was immediately preceding the symbol S and A. So we will have transitions only for the symbols S and A for state I0, right? Now in state I1, dot is not preceding any symbol, right? Dot is at the rightmost position on the right side of item, right? So in I1 state, you can see the item, right? The dot is not preceding any symbol, right? There is no symbol after the dot in LR0 items, right? The dot is at the rightmost position, right, on the right side of LR0 item. So here there will be no transitions for state I1. Now we will have transitions for state I2, right? So here you can see that the dot is preceding non-terminal A, terminal B and terminal A, right? So first we will find the transition for terminal symbol B, right? So we need to find go to I to B, right? Go to I to B. In I2 we will see those items where dot is preceding the symbol B. So this is the symbol where dot is preceding the symbol B. So we will shift this dot after the symbol B, right? Then we will get the item A derives B dot. Now we have to find its closure. So its closure will be a set having only this item A derives B dot, right? In this closure no new item can be added because there is no non-terminal symbol after the dot, right? So let us call this set as I3, right? So the transition on reading the symbol B when the machine is in state I2, right, it will be to state I3, right? Similarly for I2 state we will find the transition for non-terminal symbol A, right? So for that I'll find go to I2 A, right? Go to I2 A. So in this case what happens, a dot is preceding this non-terminal symbol A in this LR0 item. So we will shift that dot after the non-terminal symbol A, and right, then we will get this item as derives A dot, right? Now we have to find its closure. So its closure will contain only this item as derives A dot, right? No new item can be added because there is no non-terminal symbol after the dot, right? So let us call this state as I4. So here in this transition diagram I will show this transition that when the machine is in state I2 and it reads this non-terminal symbol A, then it jumps to state I4, right? Right? We have to find the transition of state I2 for terminal symbol A, right? Because here you can see that in this LR0 item the dot is preceding the terminal symbol A. So we will find the transition of this state I2 for the terminal symbol A. So in that case what we will do, in this LR0 item, right, we will shift this dot after the terminal symbol A, right? Then we will get this item. Now we will take closure of this item A derives A dot A, right? Now the closure of this LR0 item will be a set, right? And in that set that item A derives A dot A will be there, right? Now in this item when it is placed in the closure we will check the position of dot. Now you can see that dot is preceding this non-terminal symbol A, right? So what we will do in the closure, we will add items in which A, this non-terminal A is at left side, right, and the dot on the right side is at leftmost position, right? So here we will have to add these items A derives dot B, right, and A derives dot AA, right? So these two items will also be added to the closure. Now when we added these new items in the closure, again we will check the position of dot. So here you can see that dot is not preceding any non-terminal symbol, so we will stop there, right? So this set we have got. Now let it call this is the state I5, right? So in transition diagram I will show this transition. So from state I2, when it reads the terminal symbol A, then it will jump to state I5, and state I5 will have these items A derives A dot A derives dot B, and A derives dot AA. This is the state I5, right? Now we are having a new state I5, right? So we need to find the transitions of this state I5, right? So here you can see that in this item, dot is preceding the non-terminal symbol A. So we will find the transition for non-terminal symbol A, right? So for this we need to evaluate the Goto function. Go to I5 non-terminal symbol A, right? So here it will be equal to closure of A derives A dot, right? Closure of A derives A dot. So here you can see in this state I5 there is only one item in which the dot is preceding this non-terminal symbol A, right? So this dot will be shifted at the right of non-terminal symbol A, right? Then we will get this item A derives A dot. Now we have to find its closure. Its closure will contain only one item, that is A derives A dot itself, right? Let this state be I6, right? So in transition diagram I will show this transition here. So when it is in state I5, right, and it reads this non-terminal symbol A, then it will jump to state I6, and I6 has only one item, A derives A dot, right? Now we find the transition of state I5 for terminal symbol B, right? So for that we have to evaluate this Goto function. Go to I5 B, right? And it will be equal to, now see, closure of A derives B dot, right? Because here you can see that in state I5, right, only this item is there in which dot is preceding this terminal symbol B, right? So this dot will be shifted at the right of terminal symbol B, right? Then we will get this item A derives B dot, and now we have to find its closure. Now see that dot is not preceding any non-terminal symbol, right? So no new item can be added in the closure. Only one item will be there in the closure, that is A derives B dot. Now you can see that A derives B dot, right? This set is having only one item, A derives B dot, right? And what is it? It is you can see it is the state I3, right? State I3 is having only one item, A derives B dot, right? So it is I3, right? So what happens when this DFA is in state I5 and it reads this terminal symbol B, right? Then it will jumps to state I3. So here I have shown this transition. Now what we need to do, we have to find the transition of state I5 for terminal symbol A, right? So for that I need to evaluate this function. Go to I5 A, right? So you can see this item, in this item dot is preceding this terminal symbol A, right? So this dot will be shifted to the right of terminal symbol A. Then we will get this item A derives A dot A, and now we have to find its closure, right? So closure of A derives A dot A. First it will contain this item itself, A derives A dot A. Now we will check the position of dot. The dot is preceding this non-terminal symbol A, so we will add those items in which A is at left, right, and in right the dot is at leftmost position. So here we will add these two items, A derives dot B and A derives dot A, right? Right. Now you can see that this is the state I5 itself, right? State I5 is having these items, same items, A derives A dot A, right? A derives dot B and A derives dot A, right? So from state I5, on reading the terminal symbol A, the machine will jump from state I5 to I5, right? It means the DFA will remain in state I5 on reading the terminal symbol A, right? So here I have drawn this self loop, right? Now our DFA has been completed, right? Now we have found the transitions of all the states of the DFA, right? Now you can see that state I6, right? In state I6 we cannot find any more transitions of state I6, right? Because here you can see the items in state I6. Here the dot is not preceding any terminal or non-terminal symbol, so we cannot find any transitions for this state I6, right? So now our DFA has been completed. Now the next step is to construct action and go to table by using this DFA. Now we have to construct the action and go to table by using the DFA which we have constructed. In both action table and go to table, rows are labeled by the name of states I0, I1, I2, I3, so on up to I6, because in this DFA the states are from I0 to I6, right? So in both action and go to table, rows are labeled by the name of states from I0 to I6. Now in action table, what happens? The columns are labeled by the terminal symbols and dollar symbol. But in go to table, columns are labeled by non-terminal symbols. So in this grammar you can see that there are only two terminal symbols, A and B, right? And there are two non-terminal symbols, S and A, right? Now how we construct this go to table? Now suppose in DFA, right? In DFA there is a state II, right? And what happens for a non-terminal symbol A? There is a transition from state II to state IJ, right? In DFA there is a transition from state II to state IJ for this non-terminal symbol A. Then in go to table, at ith row, right, and the column which is labeled by this non-terminal symbol A, we will write J, right? So let us see how we will construct the go to table. Now see this state I0, right? So from state I0 there is a transition to state I1 for non-terminal symbol S, right? So in go to table, what we will do, in row labeled by I0, right, and column labeled by non-terminal symbol S, we will write 1, right? So it indicates that when the DFA is in state I0 and it reads this non-terminal symbol S, then it will jump to state I1, right? Now see this transition. From state I2, the DFA will jump to state I4 on reading the non-terminal symbol A. So in go to table, what happens? At row labeled by I2, right, and column labeled by non-terminal symbol A, we will write 4, right, because the DFA is jumping from state I2 to I4 on reading the non-terminal symbol A. So in row labeled by I2, right, and column labeled by non-terminal symbol A, we will write I4, right? Now see this transition from state I5 to I6, right? So here you can see that when the DFA is in a state I5 and it reads this non-terminal symbol A, then it jumps to state I6. So in go to table, in I5 row, right, and the column labeled by non-terminal symbol A, we will write 6, right? So this way go to table has been completed. Now we have to write this entries of action table, right? Now we have to complete the action table. So the first rule of action table is, if in DFA there is a transition from state II to state IJ on terminal symbol A, then in action table, at row labeled by II and column labeled by terminal symbol A, we will write SJ, right? It means shift and jump to state IJ, right? So let us apply this rule first. So here you can see that from state I0 to state I2, right? See this transition, right? Now when the DFA is in state I0 and it reads the terminal symbol A. Then it jumps to state I2, right? So in action table, in row labeled by I0 and column labeled by A, right, we will write S2, right? Similarly, you can see here, when the machine is in state I2 and it reads this terminal symbol B, then it jumps to state I3. So in row labeled by I2 and column labeled by B, right, we will write S3, right? Similarly, you can see this transition when the DFA is in state I2 and it reads the terminal symbol A, then it jumps to state I5, right? So what we do, in action table, row labeled by I2 and column labeled by terminal symbol A, right? At that entry we will write S5. Right? Now see this transition. There is a self loop from state I5 to I5, right, for terminal symbol A. So what we do, in I5 row, column labeled by terminal symbol A, we will write S5, right? Shift and jump to state I5, right? Now from state I5, there is a transition to state I3 for terminal symbol B, right? You can see here. So in I5 row, right, row labeled by I5 in action table and column labeled by terminal symbol B, here I will write S3, right? Now let us see the second rule for constructing this action table, right? Second rule which is used during the construction of action table. For that, what I need to do the numbering of production rules of the grammar. Now this grammar had three productions: S drives A drives AA, and A drives B. So here what I will do the numbering of all of these productions. This is the production number 1, this is the production number 2, and this is the production number 3, right? So what is the second rule? Second rule is that if in state II, right, and in state II there is a item of this form, A drives alpha dot, right? It means there is an item of this form in which the dot at right side is at the rightmost position, right? Then what I have to do in that case? In that case, I need to find the follow of A, right? What is the A? A is the non-terminal which is at the left of this item, right? I need to find the follow of A, and for every terminal symbol B which is in the follow of A, right, what I need to do, in action table at row labeled by II and column labeled by B, I need to write RK, right? What is the K? K is the number of this production rule, A derives alpha, right? So RK signifies that reduction by production rule number K, right? So according to this rule, if the state II of DFA contains an item of the form A derives alpha dot, then in that case what I need to do, I need to find the follow of A, and for every terminal symbol B in follow of A, what I need to do, in action table at row labeled by II and column labeled by terminal symbol B, I need to write RK, where K is the number of this production rule, A drives alpha. It will be clear when we apply this rule. Now see this state I3 of DFA. The state I3 of DFA has this item, A derives B dot, right? Now here the dot is on the rightmost position at the right side of item, right? So in this case we will find follow of A, and follow of A, if you find out, you will find that follow of A is $, right? So what I need to do, now see, this is the state number I3, right? So in I3 row of action table and column labeled by $, I will write what I will write. Now see, what is the number of this production rule, A drives B? It is 3, right? So in row I3, column labeled by $, I will write R3, right? That means reduction by production rule number 3, right? Now see this state I6. In I6 also you can see that in this item the dot is at rightmost position on the right side of the item, right? So in this case we have to find the follow of A, right? And what is the follow of A? Follow of A in this grammar, if you find out, you will find that follow of A is dollar, right? So what happens? In row labeled by I6 and column labeled by dollar, right here, right? Now see what is the number of this production rule. A derives AA, it is 2. Here I will write R2. Similarly you can see this state I4. This contains an item as derives AA dot, right? Here you can find that in this item the dot is at rightmost position on the right side of item, right? So here in this case I need to find the follow of S. So in this grammar the follow of S is dollar, right? Follow of S contains only one symbol, that is dollar, like follow of A. So see this production rule, as derives AA, as derives AA, its number is 1, right? It is number 1. So in I4 row and column labeled by dollar I will write R1, right? Because in I4 state there is an item as derives A in which the dot is at rightmost position of right side of item, right? And the number of this production rule as derives AA is 1, right? And follow of S is dollar, right? And this item is in state I4. So in I4 row and in dollar column, right, I will write R1, right? Reduction by production rule number 1. Now see the third rule which is used for construction of action table. If II state of DFA contains this item, S1 derives S dot, where S is what? This S is the start symbol of grammar, right? Then what we need to do? In action table at row labeled by II and column labeled by dollar we need to write accept, right? So here you can see that in I1 state we have this item S1 derives S dot. So in action table row labeled by I1 and column labeled by dollar I will write what? Accept. So here we have constructed this action and go to table. Now by using this action and go to table we can do syntax analysis.